Hello, everybody. So we are moving on to 1.6, which is other types of equations. So what we're going to look at today is we're going to look at different ways of solving these other types of equations. So we're going to look at solving polynomial equations by factoring, solving radical equations, solve equations with rational exponents, solve equations that are in quadratic form, and solve equations involving absolute value. So we're going to start here at solving polynomials by factoring. Polynomial equations. So when we're doing this, polynomial equations is basically anything that's not over like something else, like in a fraction form or in a radical form or anything else like that. Polynomial is where you have, like x to the fifth minus x to the fourth plus 7x squared minus 3. Those are types of polynomial equations. So that's what we're talking about when we're talking about polynomial equations. The result of a polynomial equation is when you set two polynomials equal to each other. In the equation is called general form if you have your polynomial on one side and that whole entire thing is set equal to 0. So assuming that you don't have any other numbers hiding around in there and that you have your polynomial on the left side, for instance, and then a number on and then the 0 on the right side, that's actually considered general form. And then the degree of your polynomial equation is the same as the highest degree of any term in the equation. So even if your equation is not in order, which it should be, because that's also another requirement for it to be in general form, then you need to look for the exponent that's the highest exponent within that polynomial, and that will tell you the degree of the polynomial. Okay, so here we go. We're going to start here with 3x to the fourth minus 27, or I'm sorry, 3x to the fourth that equals 27x squared. And by the way, guys, Funfetti coffee creamer is freaking amazing. Anyway, okay. So this is what we're going to do. Our first thing that we need to do is we need to get everything onto one side. So I'm going to come over here and I'm going to say, okay, I'm going to rewrite that and make it set equal to 0. So I moved my 27x squared over to the left-hand side and set that equal to 0. Now, it's simple as factoring. So this is not set up in a quadratic form, so we're not going to worry about that. So what we're going to do is we're just going to pull out what they have in common. And what they have in common is a 3x squared. Then you're going to get a set of parentheses, and then you're going to write your leftovers on the inside. Okay. Now what you're going to do is, when we did this with quadratics, we're going to take each set of this. So we're going to take this right here and this right here, and we are going to set each of those equal to 0 and then solve them. So I've got the 3x squared is equal to 0. So that means my x is equal to 0. And in this case, any monomial that's always set equal to 0, your answer is always going to be 0. So not 0. So if I've got, 15x to the 19th by itself, when I set that equal to 0, my x is just going to be 0. I'm going to do the same thing with the x squared minus 9. So then I'm going to come over here and say, okay, there I go. There's my x squared minus 9. Kick that 9 over. I get x squared is equal to 9. And then our square root property says that when you take the square root of both sides, you get x equals to plus or minus 3. So my three answers for this problem are 0 and then plus minus 3. You can verify this by plugging it into the calculator and seeing where if you put this in here to y1 and that into y2, you can look and see where everything is going to be crossed at. So let's take a look at that real quick. So I don't know why I have to do this every single time. It should just save, but it doesn't. Okay, so if I come over here and I say 3x to the fourth, and then I come here to y2 and I say 27x squared, then I'm going to say, make sure I'm at zoom standard. I'm going to graph that. There's the first one. And did that not show up? Oops. Cancel. And so they should. Oh, first off, I didn't set them equal to 0. Hold on. Let me back that up. Let's try that again. My bad. So come over here and say 3x to the 4th minus 27x squared. 1, 2, 3. There. So there's our zeros. So you have to make them equal to 0. So if you take a look here, if I plug it, so I hit trace and I go -3, I add a 0. If I type in 0, I get a 0. And then if I type in 3, I get a 0. So there are my 3 zeros, the ones that we just solved and came up with that are sitting right there. Okay? And so what you need to do is not set them equal to each other. What you need to do is move everything over to one side because we're looking for 0. And then when you do that, that is where we'll be able to figure out where I'm going to actually find all my zeros at. Okay? Let's try it again. Solve by factoring. So remember, the first thing you need to do here is, again, move everything over. And there you go. Now, just like what we did when we deal with quadratics, what we want to do is we want 4 terms. Because the first thing that we want to do is if we have 4 terms, we can come over here and say, okay, well, if that's the case, then we can split this in half and factor by grouping, which is exactly what we want to do. Because we want to see if we can force 2 sets of parentheses that are going to be exactly the same. And so when I do that, I factor the front and I get this piece right here. I factor the back and I get that piece right there. So then I combined what I factored and rewrite my leftovers, and then I wind up with that. So you want to try to get to 4 terms whenever possible, because this is the easiest way to factor. Because if you get to this point and you can't, factor by grouping, we have to do something different. And when we get to polynomials later on in the year, I'll show you what that something different looks like. Now, same as the last one, you come over here and you say, okay, well, I got the x minus 4 is equal to 0. So I get plus minus 2. And then I get this one as well. And I solve this one for x, and I get -3/2. So again, this one here and that one there are my answers. All right. So then what we're going to look at is rational equations. So unlike polynomial equations where all your answers are going to work, because you have no restrictions. Your domain has no restrictions at all whatsoever. So every answer that you're going to get in a polynomial is going to work. When you're in a radical equation, they're not always going to work. So first off, radical equation. So a radical equation is an equation in which the variable occurs in the square root, cube root, or any higher root. So basically what you're looking at is you're looking at something that looks like that. So you have some random function that sits here under the square root or this root value sign, and you have this to the nth power. What this says is we solve radical equations with nth roots by raising both sides. So I'm going to set this equal to 0. And then I'm going to raise both sides to whatever number is sitting right here. Now remember, if there's no number here, then you raise it to the power of 2. Otherwise, whatever number that is sitting right here at this end, that is what you're going to raise both sides to. So that way you can actually cancel out that root. You cannot cancel out the root any other way. So you want to make sure that when you're going through this process that whatever the n values here is here on this side, and you have to stay balanced and keep the integrity of the problem. So you have to do it to the other side as well. So this is the process that we're going to be going through. So let me give you some steps. Step 1. So we need to arrange the terms so that only one radical is on one side of the equation. We do not want two radicals on the same side of the equation. It is a nightmare. We don't want that. So we need to make sure we stay away from that. So if you have two radicals in the equation, you're going to move one radical to one side and then one radical to the other. Once you do that, then you're going to raise both sides of the equation to the radical that's on the left-hand side. So just always start on the left-hand side. So whatever radical is on that left-hand side, go ahead and raise both sides of the equation to that power. Clean that up, and if you wind up with another radical form, then you need to repeat the process of 1 and 2 over again. If you don't, then you go all the way through the problem and then you just solve the problem. And then the last thing that you absolutely 100% have to do is you have to do this step right here. If you do not do this step right here, yes, you're going to get answers. No, they're not always going to work. And you have to be able to determine which answers are going to work. Okay? You have to check because sometimes none of the answers work. Sometimes all of the answers work. And then sometimes only one out of the, 2 or 3 answers that you wind up getting will work. So you have to check each and every answer that you get when you solve these problems. So here we go. We have the square root of x plus 3 equals x. So what we want to do is we want to first thing is kick this 3 over to the other side. And when we do that, we wind up getting this. Now this is going to be a nice problem because we only have the one square root. And so because we have the only one square root, then we just square both sides. Now that I've squared both sides, on the left-hand side, the square and the square root cancel, leaving you with the x plus 3. And then you're going to FOIL out this side over here. Now, in case you don't remember, I will show you because you're going to need to know how to do this. You need to remember that x minus 3 squared is the same thing as x minus 3, x minus 3. You're going to FOIL that out, and then you wind up with x squared minus 3x minus 3x plus 9. And then that turns into that. So if you wind up going through this problem and you get x squared plus 9, you've done something wrong. You just can't square this and then square this and call it good. You have to make sure that you are writing it out into this form so that way you can get that middle term. If you see it and you don't have to actually go through it and understand, you square this and you square that, and then you multiply this and then double it. And that's where this piece comes from. So square, square, multiply, double. Okay. So now let's keep going. So now it's just a cleanup from here. Move everything to one side. You get that? We're going to factor this quadratic. We're going to factor this quadratic that we did in the previous section. And then we get that. And then we get both x values here. And we get that. So now we're not done because what we have to do is we have to take these x values here and we have to take these and we have to go back up to the original equation and plug them in up here and see which one actually works. So if I plug in my 6 here and here, I get 6 plus 3, that's 9. Square root of 9 is 3. 3 plus 3 is 6. That works. So the 6 works. Do the same thing with the 1. 1 plus 3 is 4. Square root of 4 is 2. 2 plus 3 is 5. 5 does not equal 1, so the 1 does not work. So when we're looking at this, then what we wind up having is that our 6 works and our 1 does not. So the only answer that we have is going to be 6. And so there's an easy way to check You come over to your calculator. Now, the difference from what we were looking at on the polynomials, we were actually looking for zeros. That was my mistake. So in the polynomials, you'll move everything over to one side, set it equal to 0. So you'll make that all of a y1. Here, because we're trying to figure out which one makes both sides of the equations balanced, this is going to be your y1 on the left side and your y2. And when you graph them, you're going to get something that looks like that. Because you get something that looks like that, what we're going to look for is this intersection point right there. And if you notice, that intersection point is going to be 6. And so since that intersection point is 6, it matches the answer that we got over here, which x equals 6. So therefore, we are good to go. Let's try it again. So I'm going to give you this. Oops. Oh, this piece here, this is just a reminder if you forgot how to go through the factoring piece. So if you're like when you have the 1 in front of it, so if you're just trying to remember how to factor, this is what everything factors down to. So if you have your quadratic in this format, you're going to have something that looks like this. If your quadratic is in this format, you have something that looks like this. If you have something that's in this format, you have something that looks like this. And then if you have something in this format, you're going to have something that looks like that. So that's just a refresher on what it looks like when you are trying to factor a quadratic equation that has a 1 in front of it. So now what I want you to do is I want you to take a few moments, pause the video, and I want you to go through and solve this equation and see if you come up with the right answers. Make sure you check your work. That's the key thing, is making sure that you are checking your work. All right, go ahead and pause it now. All right, welcome back. Hopefully you were able to go through the problem. So let's see what we actually got here. We go through the whole entire process. You wind up with this. And then you can check your work. Oh, where is it? Okay. Yeah, I guess I didn't write that down. I thought I did. So when you plug it back in, you'll realize that the 5 works and the 1 does not. And again, if you want to check it to see that if you got everything correct, this piece over here is your y1. This is your y2. Stick that into the calculator, and you will see that it intersects at x equals 5, and that's the only answer that you have. All right. So now we've looked at our equations that we've looked at where you only have one radical on one side. But what happens when you have problems that look like this? So we're going to have to go through this whole entire process a couple of times. So if you are taking notes as we're going, what you're going to need to do is pause the video real quick and make sure you have enough room, because this takes about a little bit more than half of a page. I guess you don't have to pause the video at all. But it takes about half the page to do this problem. And then if you're doing the side problem as well, it's going to take up a little bit more. So if you actually have a full sheet of paper, you're going to be just fine. But if you're down towards the bottom of your notes, I would recommend going to the next page. So here we go. The first thing that we're going to want to do is we're going to want to move one of these radical signs over to the other side. And so since I have this negative sign here, I'm going to go ahead and move the square root of x plus 4 over to the other side. And then I'm going to square it. So now, before I go any further, we already know that this is going to be the easy side, because when I take the square root of a square, I get the 3x plus 1. But then you have this bad boy that sits over here. That square root, for a lot of people, it makes them uneasy. So here, I'm going to show you something different. So I'm going to go to the next screen, and we're going to look here. So this is what I want you to do. We're not going to tackle this problem as 1 plus the square root of x plus 4. What we're going to do is we're going to tackle this in an easier format. So the first thing I'm going to want you to do is I want you to say this. I want you to let y equals the square root of x plus 4. Okay, so if I do that, then what I'm going to wind up is I'm going to wind up actually factoring this piece here. And this makes your life a whole lot easier because now you're not trying to figure out what am I supposed to do with this square root. So now what you're going to do is go ahead and factor this normally. And when you do that, you get this. Okay, so now you're done. Okay, so you've expanded this out like you're supposed to, and you're done. Except now we have y's, but we don't have y's in our original. We have square roots. But we have a y and a y squared. So I'm going to come back over here and I'm going to say, okay, if y equals the square root of x plus 4, that means that y squared equals x plus 4. So then I'm going to take this information over here and plug it back in to my newfound equation over here, and then I wind up with this. So if you notice, here is my y right here. So this y and that y. And then here's my y squared right here. That's this piece right here. So all I did was replace. And so now this is an easier cleanup now than what you had if you didn't go through that process. So I'm going to keep cleaning up this piece over here until I can't do it anymore. And then I wind up with that. There's nothing else I can do with that. So I'm going to take this piece and I'm going to go back to the previous slide. And this is going to be what my right side looks like. So what I'm really looking at is, now that I'm here, what I'm really looking at is this. So this is what I'm actually going to solve, is this piece right here. So now what I'm going to do is, I've got a square root sitting over here on the right side and all this other stuff back here. So I'm going to move all this other stuff back here over to this piece over here. And so when I do that, I get that. Now I have a really pretty situation here. I have this 2 right here, and both of these over here are divisible by 2. So I'm going to go ahead and divide everything by 2 and just make my life a little bit easier. And then I'm going to square both sides. So when I do that, I'm dividing everything by 2, and I wind up with the x minus 2 and then the square root of x plus 4. And now I've got the problems that we worked on the previous slides. So now I'm just going to square both sides. And then I'm just going to move everything to one side. So I squared both sides here, and then I moved this piece over to this side. And then I factored this. This is what we did in the very beginning. So see how everything is coming back with each other? Set each piece equal to 0 and solve. And then make sure you check your answers. And then when you plug everything in, when I plug in the 0 in, I do not get my left side equaling my right side. But when I plug in the 5, I do get my left side equaling the right side. And so therefore, the only answer I can deal with is going to be that one. All right. So hopefully that wasn't too bad. It's just a lot of algebra is really all it is. And making sure that you stay balanced and everything combines nicely. The key thing, hopefully, that you're taking away from when you're solving radicals is the fact that you have to check your work every single time. Because, as you've seen, not all your answers work. And so you need to make sure, because you're going to have some times where none of your answers work, and that's okay. It is absolutely okay to have none of your answers work. And then you're going to have some times where both of your answers work. And that's okay as well. So if you go through the process and find out that the first one works, don't just not do the second one, because if you do that, then you may miss out on another answer that you possibly could have had. So please make sure that you stick through the whole entire thing to make sure you're actually getting the correct answers. All right, so let's move on. Oh, just did that one. Now we're going to deal with rational exponents. Rational exponents are when you have something that's basically like this. Your exponent is in a fractional form. And when you have an exponent in the fractional form, this piece here is going to turn into this piece. So your numerator is going to be actually attached to your variable. And then the denominator is going to name your root. Okay, so the numerator is going to raise your variable to that specific power, and the denominator is going to be the name of the root. And so remember, when you're going through these and you're trying to solve these, you're going to want to undo the root, and then you have to root the top. So I'm not sure what I'm talking about in this because it's going to sound a little weird. But, and when you're going through this, now here's the key when you go through the rational ones. So when you're going through this, you might start with the top on the first one and then do the root, and then do the root on the bottom one on this problem. But the next problem, you might want to do the reverse of that. It's just going to be depending on what makes the problem easier. So it's not a specific, you have to do this one first and then you have to do this one. It's whatever's going to make the problem easier for you. So here we go. So I'm looking at this here, and I've got 5x to the 3 halves is equal to negative 25. So the first thing I'm going to do is I'm going to say, okay, I'm going to move that 25 over. So I get 5x to the 3 halves, and that's going to equal a positive 25. And so then what I want to do is say, okay, well, I don't really want to deal with this 5 here because mind you, this exponential piece is only on the x value. It does not attach itself to the y value. I'm sorry, to the coefficient value. So we need to go ahead and we need to divide both sides by the 5. So that gives me this. And so now from here, you decide on what you want to do. So if I'm looking at this, I'm going to approach this 2 different ways. So it's going to be your choice. I'm going to show you both ways. So we're going to start off in red. And in the red, we're going to start by squaring both sides. I'm going to get rid of the denominator first. And when I do that, I wind up with x cubed is equal to 25. And then I'm going to take the cube root, which is to the 1/3 power. And so that I wind up with x is equal to 25 to the 1/3. Or I could say the cube root of 25. And since I do not know what that is, I just leave it alone. I don't do anything else to that. It's just, it is what it is on this one. Okay. If you want to approach it from a different direction, you can approach it from doing this over here. So I'm going to come back over here. X to the 3/2 is equal to 5. So I can actually start with my root value first. And that will leave me with x to the 1/2 is equal to the cube root. Oops, the cube root. That was ugly. The cube root of 5. And then I can square both sides here. And then I wind up with x is equal to the cube root of 25. So if you notice, however you approach it, it doesn't really matter. Okay. You'll wind up with the same answer. Sometimes your answers, it might look prettier by starting off in the green route, where you start off by getting rid of the numerator first. And in some problems, your answers might look prettier by starting by getting rid of the denominator first. So it really depends on how you're approaching your problem. So let's look at a different one. Now we have a bunch of fractions here. So I've got x to the 2/3 minus 3/4 is equal to negative 1/2. So the first thing I'm going to do is move that 3/4 over. So I wind up with x to the 2/3. When I add 3/4 to both sides, sorry, when I add 3/4 to the both sides, I wind up again with 1/2 because I wind up with 2/4. So just in case you're wondering, 1/2 plus 3/4. Well, instead of being 1/2, what I'm really going to be is 2/4. And so that's my 1/4. Oh, I was wrong. My bad. It's 1/4, not 1/2. See, that's why you do your work. You don't do your work, you make mistakes. All right, so now what I want to do is I want to go through this and try to figure out what should I do now. Again, it's going to be your choice. So what I'm going to do is I'm going to start off by taking the square root of both sides. So I'm going to do the square root of both sides, just like that. So that leaves me with x to the 1/3 over here, and then the square root of 1 over the square root of 4. Square root of 1 and the square root of 4. Oops, not that. Is equal to 1/2. See, I done jumped ahead. That's where that 1/2 came from earlier. Now what I want to do is I want to go ahead and I want to get rid of my third root. So I'm going to raise both sides to that power. And so when I do that, I wind up with x is equal to 1 cubed is 1, 2 cubed is 8. So I wind up with 1/8. And you're done. Okay, so when you go through this process, make sure you keep everything in order. Make sure you do your work like you're supposed to, because you don't want to make the same mistake I did when we started out with this. So keep everything in order and pick however you want to approach it. Now, that was it for rationals. Now we're going to look at equations in quadratic form. This is not quadratic equations. These are quadratics, or these are equations that look like a quadratic equation. So what you're looking for is this. You're looking for a quadratic equation, or I'm sorry, an equation that has an even power here and then half of that even power there. So if this front power was 8, this needs to be to the 4th, and then whatever you're adding to that in the back. So that's what we're going to be looking at as we're going through these. So even powers on the first one, and then half of that for the second one. And that's going to be in quadratic form. So let's take a look at how we're actually going to approach these. So I have this equation. It's to the 4th power. They want me to solve it, and you're looking at it and go, I have no idea. The good news is that you have an even number, and then your second term is half of that even number. So that's a good thing, because now this is what we're going to do, and you need to be very specific on this piece. We are going to say, okay, I'm going to let y equal x squared, because that means that y squared will be equal to x to the 4th. So we're going to do some substitution here. So we're going to let y equal x squared. So we're going to let it equal this middle term. Whatever this middle term is here, that's what we're going to let y equal. And because of that, we wind up with y squared. It's going to be equal to x to the 4th. So now what I'm going to do is I'm going to rewrite our original equation. I'm going to say, instead of x to the 4th, because x to the 4th is y squared, I've got y squared minus, instead of 5x squared, I'm going to have a y. And that plus 6 just sits there. Factor this normally. So factors of 6 that add to give me a negative 5. So that's y minus 3, y minus 2, and that equals a 0. So now I'm here. I'm not done. I'm 90% of the way done. because I'm in terms of y. Our original problem was in terms of x. So I have to take this piece up here and plug my things back in. So my y is x squared. So I'm actually looking at x squared minus 3, x squared minus 2. That's equal to 0. And you know from our zero product rule that says, okay, now that I have this, I can say x squared minus 3 equals 0. X squared minus 2 equals 0. So I get x squared is equal to 3. So x is equal to plus minus the square root of 3. I get x squared is equal to 2. So I get x is equal to plus minus the square root of 2. And then these are my answers here and there. When you go through these, sometimes you're going to have pretty numbers, sometimes you're going to have these roots. Just make sure you simplify your roots down. These are going to be polynomials, so pretty much whatever you have here is how many answers you should have. Now, you can have repeating answers. That's okay. That is still considered part of the answer, okay? So if I've got 4, I better have 4 answers down here. That's okay. We can do that. So let's try this again. Notice here, these are fractions. And so when we do this, it's the same thing. We are going to say let y equal x to the 1/3, not 1/2. X equal, see, look at me. Y equal x to the 1/3. Therefore, y squared is equal x to the 2/3. Okay. Rewrite it. So we've got 5y squared plus 11y plus 2 is equal to 0. I'm going to factor by grouping here. So factors of a times c that add to give me an 11. That's going to be 10 and 1. So my 11y is the same thing as 10y plus 1y. I'm going to rewrite my equation. 5y squared plus 10y plus 1y plus 2 is equal to 0. I'm going to cut it in half. I'm going to pull out a 5y, y plus 2. In the back, they have nothing in common, so I'm going to pull out a 1, y plus 2. And then I wind up with 5y plus 1, and y plus 2 equals to 0. And now remember, my y value is x to the 1/3. So I've got 5x to the 1/3 plus 1 is equal to 0. And x to the 1/3 plus 2 is equal to 0. And now we solve it. 5x to the 1/3 is equal to -1. I'm going to go ahead and divide through by that 5. X to the 1/3 is equal to -1/5. I'm going to cube both sides in this case. So I wind up with x is equal to -1/125. Because remember, I am cubing this whole thing. I'm going to do the same thing to the other side. X to the 1/3 is equal to -2. I'm going to cube both sides, and so then I wind up with -8. Again, if you're not sure, plug it back into the calculator and see where this crosses the x-axis at. So you take this whole entire thing here, plug this into the calculator, and you're going to look and see where it crosses. All right, so questions on this hopefully are, it's not that difficult. You will notice that we only have the one answer here and here, and we have the 2/3 answer here. That goes back into this piece right here. Because this is a fraction, it's going to default to the this piece here. So let's take a look at this, which of course I'm going to have to go through this process again. Maybe. There it goes. Browse that, this, finish. All right. So this was, oh, it won't let me. All right. So this was 5x to the 2/3 plus 11x to the 1/3, and then plus 2. So you take a look. So this is the first one. That's going to be kind of easy to take a look at because you can just count it and see. I can go trace -8. There's my first 0. The other one is really, really, really hard to see. So you go -1 divided by, I think it said 125. And then there's your 0 right there. So both of those answers are correct, and both of those answers will work. All right. So let's try again. So take a few moments. I want you to go through this and see what you come up with. So hit the pause button on this, and then we'll check back in, and then we'll see where you're at. Okay. Take a few moments to go through this, and let's see what you wind up with. All right. Welcome back. So on this front piece, we get x to the 4th plus 10x squared. No, not 10, not plus, it's minus. Plus 25 plus 3x squared minus 15 minus 10 is equal to 0. So we have x to the 4th minus 7x squared. This 25, and that'll be a negative 25. So these are going to cancel, and that leaves you with this. Okay. So this is going to be an easy one to do. So you factor out your x squared. And you have x squared is equal, not equal, x squared minus 7. This is all equal to 0. Then you have x squared is equal to 0. And then you have x squared is minus 7 equal to 0. X squared is equal to 7. So x is equal to plus minus the square root of 7. And then that means that this x is equal to 0. Now I told you earlier, this tells you how many answers you're supposed to have. So I've got 1, 2, 3 answers, but technically I have 4 because the square root is a plus minus 0. Well, a positive 0 and a negative 0 are the same thing, so that's why you only have 1. But if you honestly think about it, there's a plus minus sitting right here that you don't see because it's a 0. So there are your 4 answers. Okay. So remember, when you have equations in the quadratic form, you're able to look at those equations in the quadratic form and then do a u substitution or a y substitution or whatever substitution that you want to use, because that's what we did. It's called a substitution. And that way you can force that quadratic to happen, and then using your quadratic skills that you've already acquired, then you can go through and actually solve the problem. All right. Absolute value. These are kind of fun, in my opinion. I know, I'm a little weird. Absolute value. So when you have equations in the absolute value, we're looking for how far away are we from the origin. That's what we want to know. And so when I'm looking at that, we want to see basically how many answers do I have that's going to wind up being away from the origin. And when you do this, you have to remember that the absolute value of something, first off, has to equal a positive number. If you've got the absolute value equaling a negative something, you have a no solution. You can't do the problem. You write no solution, go to the next question, because you cannot do it. Now, if there's things that you need to move to the other side, that's completely different because you're manipulating everything. But if you've got absolute value of blah equals a negative blah, that negative blah doesn't exist because the absolute value can never equal a negative number. It can only equal a positive number. But when you take the absolute value of both sides, you wind up with two answers. So if I've got the absolute value of this, I can do this because I can have x is equal to 7 and x is equal to negative 7. Because I'm always going to get a positive 7. Because you have to remember, since absolute value means distance, distance is always positive. But if I throw a negative on here, there is nothing that you can put in that x place that will actually give me a negative 7. The only exception would be is if you had a negative right here. That would be the only way you're going to get a negative 7 as an answer. So when you're doing these, if you see something after you've done your manipulation and it still equals a negative value, you cannot do it. Does not exist. No solution. Whatever the question says, and then go to the next question. So let's take a look at these. So the absolute value of 2x minus 1 is equal to 5. So you will always do two problems here. You're going to do the one that's written. 2x minus 1 is equal to 5. And then you're going to do the one that's not written. 2x minus 1 is equal to negative 5. Because you have to do both of them. And then you're going to solve. So since I'm already in blue, I'm going to go ahead and solve over here. Divide by the 2. X is negative 2. Over here in red, 2x is equal to 6. X is equal to 3. Just like before, you need to check your answers because sometimes these answers don't work. So 2 times 3 is 6, minus 1 is 5. The absolute value of 5 is 5, so this one works. 2 times negative 2 is negative 4, minus 1 is negative 5, but the absolute value of negative 5 is positive 5. That one works. So in this case, both of your answers work. You're done. Let's try it again. So on this one, I know this one looks really bad. First thing I want to do is I want to take care of that negative 15. I'm going to move that to the other side. So I get 5, absolute value of 1 minus 4x equals 15. I want to take care of this 5 right here. So I'm going to divide both sides by 5. So what I'm really looking at is 1 minus 4x, absolute value, is equal to 3. Just like before, now that I'm here, I'm going to say 1 minus 4x is equal to 3, and 1 minus 4x is equal to negative 3. And then we're going to solve it. So negative 4x and I move the 1 over, I wind up with a 2. Divide through by the -4, and I get -1/2. Over here, when I move the -1 over, I get -4x is equal to -4. And then I'm going to divide by the -4, so I get x is equal to 1. So when I come back up here and I plug this in, I get 1 minus 4, let's see, 1 minus 4 times -1/2. That winds up with a positive 2, so 1 plus 2 is 3. 3 times 5 is 15. 15 minus 15 is 0. That works. Same thing with the 1. 1 minus 4 times 1 is -3. Absolute value of -3 is +3. 3 times 5 is 15. 15 minus 15 is 0. That one works. Okay, and you're done. Let's try one more. This is what I was talking about earlier. So if you have an equation that looks like this, it's empty set. There's nothing you can do with this. It's empty set. It's no solution, or it does not exist, D and E. So it's going to be, I'm not sure how your textbook on the homework has it. It's probably going to be one of these two. I think it's more so that one. So when you go through your homework questions, make sure you're taking a look at that, and that way you can figure out which one it's going to wind up being. Okay. So I know we just went through a lot here. So if you need to go back and rewind and look at bits again, feel free to. If you have questions, comments, concerns, or anything like that, please let me know, so that way we can go through and I can answer your questions and everything. But this will conclude 1.6, which is other types of equations. You can now start your homework on that. So I hope everybody's doing well, and I will see everyone soon. TTFN. Ta-ta for now.